Fine. So if you see what is objective of this training, see objective of this training is to ensure that you are able to programmatically manage, various different AWS object. And also, you should have capability of bringing in data from external environment to your AWS storage, and also how actually you can create two-way communication, how you can provision infrastructure of your AWS using Terraform. So this is what in brief is objective. But today what we are going to do is, I thought that we'll quickly have a recap because many of you might be new to AWS, if not entirely new, because AWS has been evolving. And if you compare its services as well as UI as compared to, a quarterback also, you'll find huge difference because they have been innovating, and they have been bringing in lots of other services. And apart from that, they have been adding extra capability to existing services because cloud need to upgrade frequently as and when there is some kind of development in appliances as well as development requirements. So with that objective, what I will do, I will try to sync with you and understand that what is your current understanding and how actually AWS has been changing. So this is a fundamental session that I'll be taking in order to bridge the gap between you and me, so that we have common understanding about the platform on which we are going to work for all these days. Okay. So anything should start with basics, and that's the objective. So if you see, for next 20-25 minutes, we will be talking about understanding AWS and how actually AWS cloud is spread across multiple geographies. What all are the important components? How do we interact with AWS, right? And some of the use cases with focus on certain essential services. So this is what is the objective. Now, if you see history of cloud, I will not spend much time here, but I just wanted to tell you that, when HTTP came, from there onwards, people started thinking of distributed computing more, and also collating resources and distributing resources using HTTP protocol. Right. So from there, if you see, there is a steep in terms of infrastructure distribution as well as availability. And if you see, when actually AWS was launched, it was in 2002. Right. And from there, multiple other providers came up because of event of big data. Google also came up in cloud domain. Then Azure was launched. Right. And then came CDN market because, your services now need to be distributed across globe and you want to serve them quite quick. So what you need to do, you need to ensure that data is located from wherever that particular visitor is visiting your content. And that's where CDN came into market, where your data was distributed geographically and the consumers were served from their geography itself. Right. So this is what is brief history of cloud. And still, this is going on. IoT has come in. So IoT has been integrated. AI has come in. So AI has been integrated. Machine learning capabilities have been integrated. So this keeps on, improving. And that's the reason why we cannot say that once I went through cloud in 2010 and I'm comfortable today as well. So you have to grow with the way cloud is changing its dimension in terms of providing services. But we all are lucky because cloud term was, coined by an Indian, right? His name was Ramesh Chelappa. So this is what is brief history of cloud. Let's go and talk about what is the distribution model of cloud computing or cloud services. So it can be actually classified into multiple different types. When I talk about hosting my service on cloud, it falls under which category and how actually we are going to demand kind of service that is required for our need. So if you see at the bottom, you have data center and facilities services. I mean to say where your hardware, appliances and other things are kept. Vendor supported, consumers subscription managed or subscriber managed, and then abstracted by provider. So whatever is the hardware provider, objective of data center is to ensure that it hides, the low level layer and facilitates end user by providing various different types of services, right? So let's start with first one, that is infrastructure as service. Now, if I'm asking for infrastructure as service by, from the cloud provider, it basically involves what all, right? That is what is something that we need to understand. Now, if you say infrastructure can be facilitated in two different ways. One is by virtualization and second is by containerization, right? Because containers have come in rescue for shipping our applications wherever we want. So when I talk about infrastructure as service, either I'll be asking for virtualized component or I'll be asking for containerized component. So both of them actually facilitates infrastructure to us. And infrastructure is what? It is CPU, it is RAM, it is network, it is storage. All these are part of infrastructure as service. So when I ask for infrastructure as service, it means I'm asking my cloud provider that, see, I need infrastructure components from you. I don't want you to set up platform on which my application is going to run, right? So when you are asking infrastructure as service, it is your responsibility to provide application runtime, which will be application servers or a platform. And then on top of that, you have to deploy your applications, and applications will be composed up of multiple independent functions. So from whatever you see in blue is what is your responsibility. What your cloud provider will provide as a request of asking infrastructure, they will provide you containers or virtual systems powered by selected or desired operating system of your choice. Now you say that, hey, I don't want only infrastructure. I'm not interested in going and configuring platform or application runtime. I want you to do that for me, right? So that's where platform as a service comes into picture, where I say, give me a configured environment where I can deploy my Java application, Go application, Node.js application, or application of my choice. So you have to tell your cloud provider, demand your cloud provider to provide you infrastructure configured by platform, where you will take responsibility of just writing functions, bundling it in form of application, and deploying it on platform or the runtime, right? So here again, your responsibility reduces. Then comes, okay, I don't want you to just facilitate me platform. I want you to facilitate me with application also. I will just write function. All the wiring, dependency management of that application, configuration of that application, you have to take care. And that's where function as a service comes into picture, right? And believe me, all cloud providers are following same paradigm of providing you services. Now, finally, you say that I don't want to write even functions. What I want is, I'll tell you, can you give me a catalog of accounting software or inventory software that I can directly start using? That's where software as a service comes into picture, where you are not responsible to write application function. You are just consumer of already deployed application, fully functional application. By just subscribing to that particular software, you will start using it in your business domain, right? So these are 4 critical or typical services which are provided by cloud. Now there is extension also of this. Some terms you might have heard about, machine learning as service, IoT as service, artificial intelligence as service, database as service, analytics as service, right? So all these are now provided by cloud. You have to just go and subscribe for appropriate service and start using it. So this is what you can consider as today's cloud computing model. Extension of SaaS, I told you, that is machine learning as service, IoT as service, artificial intelligence as service, database as service, analytics as service. All these are now provided to you out of box by your cloud providers. So now we are aware about what we need to demand. So depending on your requirement, you can plan either I need infrastructure, or I need platform, or I need function as a service, or I need software as a service, or others that I discussed. Now comes, okay, fine, I understood this. Just a couple of seconds, why actually cloud? See, there are 2 schools of thoughts. One says that, see, in all cases, cloud may not work. I'm not confident because I'm keeping my data in cloud, as per compliances, as per governance policies, it may not be allowed, right? But still, I may like to use cloud because cloud provides me certain features, and wherever compliance is not an hindrance of utilizing service, probably I will think or plan of adopting cloud because cloud provides me great availability because it does internal housekeeping. It takes care of disaster management also if I'll ask it to take care. It also provides me capability of adopting measured service. I mean to say I will pay as I use the service. I will not pay for procuring the service. In short, you are moving from capital expense to operational expense, capex to opex, right? So that's where measured service and pay as you go comes as part of cloud, and all cloud provider does that. Yes, their billing rate may be different, their billing metrics may be different, but at the end of the day all of them will charge you depending on the usage. Then comes easy maintenance because I don't need to maintain hardware, networking, physical component, electricity. All that is not my responsibility, right? I need to just maintain my platform, my application that I am hosting on cloud. It is economical. Why it is economical? Because I pay as we use it. Resource pooling is what internally used by cloud, which helps us to do more with less resources. On-demand service, on-demand self-service is another feature that is facilitated by cloud. And also automatic system in the sense, for example, you want to specify a condition that, hey, if my CPU usage grows more than 90%, please go and automatically spin another instance, right? So that is automated. You can implement lots of automation in terms of consumption, metering, as well as keeping track of what is internally going on without any manual intervention. So these are some of the features of cloud which makes it an obvious choice. But yes, please remember, it should not actually be a hindrance when it comes to compliances. So keep in mind, governance and compliances sometimes may restrict you to use cloud, but when it talks about overall operational features, overall cost, overall maintenance, better ROI, cloud can be one of the obvious choice. This is the reason, why most of the companies now are coming up with hybrid cloud, where whatever is restricted by compliance to be kept and executed on cloud is there on-premise, and rest of the services are there on cloud. So hybrid cloud is something which is picking up today in almost all organizations. Now, what all are the cloud deployment models? See, you are going to write applications. So sometimes you have to bring in data from two different cloud to one cloud, right? And that actually is possible only if your architecture supports it. So keeping in mind your requirement, you have to adopt appropriate cloud deployment model. So let's see, 4 cloud deployment models which are popular today, and try to classify it on basis of certain parameters. Parameters, if you see, is there on the left hand side, and on the right hand side these parameters are populated with appropriate feature for public, private, community and hybrid cloud, right? So if you see ease of use or ease of setup, public cloud, you don't need to do anything, right? You need to just know what actually you want to ask from public cloud. Private cloud, it means you are setting up your own cloud. So you have taken up OpenStack, bare metal, and now you are going and you are setting up your own cloud. It's very hard because you need to be aware about proper virtualization, network mechanism, addressing scheme, and whatnot, right? So it's very hard to set up as your team has to create it. Then comes community cloud, where 2 or more than 2 companies want to set up their own cloud together. So it's private cloud, but its scope is more. It's company A, company B, and company C. All 3 are participating in order to build a cloud. Then comes hybrid, which I told you. It's complex to set up because you need to interconnect systems on-premise with public cloud. Then you have another type of cloud, which is not mentioned here, called as multi-cloud. Now, multi-cloud is similar to hybrid cloud, except one difference. And that difference is in multi-cloud, you need to have at least two public cloud connected together. You can have Azure, AWS, and on-premise. Hybrid cloud, one public cloud and one private cloud is fine. Ease of use, very easy to use, obviously. Complex, relatively easy as compared to private. Hybrid, difficult to use if the systems are not configured and set up properly. What about data control? See, low provider has complete control. Okay, provider of data. Private cloud, very high ownership is with your system. Community high if member collaborate better. Hybrid cloud, very high with right setup. So this is what is from perspective of data control. What about reliability? In past, you might have seen that Google Cloud was down. Okay, and all the Google services were impacted. So there are multiple instances that we have faced, where AWS cloud was also down. So if you see, it is prone to outage and failures, but there is good SLA, 99.99999%, right? Private cloud, high reliability because everything is in your control, so you can have multiple clusters. Community cloud depends on the community policy, and hybrid cloud, high with the setup. So you can see one of the risks which is there because public cloud is not owned by you, so you cannot 100% guarantee reliability. Then comes scalability, low. Most providers offer limited resources and predefined setups. Private, very high, it's in your hand. Community, fixed capacity. Hybrid cloud, high with right setup. Then comes cost, inexpensive. Private cloud, very expensive because you have to procure hardware as well. Community cloud, comparatively cheaper because members will share the cost. Hybrid cloud is cost effective because you are getting best of both worlds. Demand for in-house hardware, there is no demand here in case of public and in case of community. But in case of private cloud, in-house hardware is preferable. Hybrid cloud, in-house hardware is not a must, but sometimes you need to procure it because all the load that is there, whenever there is need of any hardware, you push it to your public cloud and you manage services there, right? So these are various different cloud deployment models that actually you need to consider when you are architecting your cloud environment.